Hello, today let's try to understand the basic concepts of ROS by a very fun and engaging game of tag wherein there are two turtle bots trying to chase each other. One runs randomly across the screen and the second turtle robot tries to chase it or catch it. This is a fun game of tag wherein we'll be trying to understand how the robots communicate with each other using a very fundamental concept, you guessed it, called ROS. ROS is basically, it stands for Robotic Operating System. Now, when you hear this word, it's not like a common operating system like Windows or Linux. In fact, the robotic operating system is a communication system for robots to communicate with each other. It helps different parts of a robot to interact with each other. So you can consider ROS as a medium like WhatsApp or maybe like a walkie-talkie for robots to communicate with each other and share information with each other. Here are a few concepts of ROS which you must know before we implement our program. First is ROS node. What is a node? You can consider a node something similar to a program. So a node is similar to a program, or in our case, in today's example, it's going to be a Python script. One example is of that randomly running robot or turtle bot which runs across the screen randomly. So there's a Python script designed to do just that. And it is one node in our today's example. The second concept that you must know is of ROS topic. Topics are basically used to send continuous messages. When I say that, you must know that nodes make use of two things: publisher to send messages related to a certain topic, and subscriber to basically listen for those messages related to the same topics. The third concept that we must know is of ROS services. Services are based on request and response. We will be seeing a short example of a ROS service in a while. Let us start by writing the codes. Our first code is basically we'll be typing ROS core. What this does is it starts the ROS master. Without this, nothing works. For example, if you had to send a WhatsApp message to your friend, what you would require is a Wi-Fi connection. You can consider ROS core to be doing the same work. It is like turning your Wi-Fi on for the robots to communicate with each other. The second is when you write the command ROS run turtlesim node. This is our first node that we are creating for today. The work of this is it opens a simulator wherein we can see our turtle1 robot is already there in the screen. We can see the screen, it creates turtle1 robot and it publishes poses automatically. So we now know the poses of turtle1 robot. We now need our second turtle. For this, we make use of the ROS service. We write a command ROS service called spawn 550 turtle2. What we are doing with this command is we are telling the ROS to basically, we are requesting it to create another turtle called turtle2 at the location 5, 5. Since it's a 2D plane, x and y values should be 5 and direction should be 0, which is by default the right direction. So we created our second turtle robot. Now all we need to do is start our game, for which we need our second and third nodes. The second node is for the first turtle to be able to run randomly across the screen. So we type the command ROS run hw1, which is the file wherein our Python script is stored, and we type the name of our Python script. The function of this node is to publish random movements. We, on running this, can see that turtle1 has started running across the screen randomly. After this, we will start our final node, which is the chasing turtle node. The purpose of this node is to subscribe to turtle1's pose and publish movements to turtle2 so that it can chase turtle1. So once we run this command ROS run, the same file directory hw1 where our second script of chasing turtle node.py, this Python file is stored. Once we run this, you can see that our second robot has started chasing the first turtle. So in short, if you had to describe how ROS is working and helping these two robots communicate with each other, if you have to summarize, this is what is exactly happening. We have three nodes in total: the turtlesim node, the random turtle node, and the chasing turtle node. The random node publishes velocity for turtle1. The turtlesim node, which we have, subscribes to this and moves turtle1 accordingly. Turtlesim also publishes the turtle1's pose so that the chasing node can subscribe to it. It reads this pose, listens for it, and then accordingly it sends turtle2 the velocity so that turtle2 moves in the direction of turtle1. Turtlesim then moves turtle2 by listening to the pose that turtle2 had generated, the chasing node had generated. Turtlesim uses that to move turtle2. This is the entire way in which our ROS program is working, and these two robots are using ROS to communicate with each other and make the entire game work. Thank you very much.